Often the domain of a function f is not specified. Instead, the equation defining the function is given. In such cases, the domain of f is the largest set of real numbers for which the value of f of x is a real number. So to find the domain of a function, you should follow these steps. First, we're going to start with the domain as a set of real numbers, and you can just say that as negative infinity to positive infinity here. Now these are the two steps you have to follow. If the equation has a denominator with variable or variables, exclude any numbers that give a zero in the denominator. And to do this, you're going to set the denominator equal to 0 and then exclude those values. If the equation has a radical with an even index, exclude any numbers that cause the expression inside the radical or the radicand to be negative. So what we're going to do is not so much find what's negative and get rid of those, except we're going to find what actually works and just keep those instead. So let's start with the first function, f of x equals negative 5x plus 4. So we're going to start with our domain as negative infinity to positive infinity. And now we're going to look. If the equation has a denominator with variables, this equation has no denominator with variables. So we don't have to worry about 2. We can just kind of cross that out. Now 3. If the equation has a radical with an even index, this has no radical, thus no need to worry about an even index. Since 2 and 3 don't really matter in this function, we can say that the domain is negative infinity to positive infinity, and we don't have to do anything else. Next, g of x equals 9x over x plus 1. Again, we're going to start off with our domain as being negative infinity to positive infinity, and we're going to go from there. Now again, if the equation has a denominator with variables in it, this has a denominator with variables in it. So what we're going to do is we're going to take the denominator. We don't care about the numerator. We just kind of cross that out for now. And we're going to set it equal to 0. Now we're going to solve by adding 1 over. X is going to give us positive 1. And like it says up here, exclude any numbers that give 0. And what gives 0 is 1, so we're going to get rid of 1. So in our domain, we're going to have from negative infinity, and we go along the number line until we hit our first problem, which is 1 here. And we're going to just kind of skip around it like so. So we're going to say 1 parentheses union parentheses 1 to infinity. And this would be the domain of this function. But I know this can look a little weird, so if you were to kind of visualize it on a graph, just as a quick aside, it would look like this. 1 here, but an open circle here, meaning it can't equal 1. And the domain would go all the way to the left, negative infinity forever, and to the right, positive infinity forever. So this union just kind of means we're going to go up to 1, kind of just skip around to the other side of 1, and then keep going. Next we have h of x equals square root of 3x minus 15. Again, we're going to start off with our domain as negative infinity to positive infinity. And we're going to see if there's a denominator with variables in it, which there is not. And then we're going to see if there's a radical, which there is, with an even index, which this is a square root, so it does have an even index. So instead of finding the values that don't work for this, we're going to do something a little bit different. We're going to take what's inside the radicand, 3x minus 15, and we're going to find out what does work. And remember, we can't have a negative under here, so anything can be positive or 0. So we're going to set this as greater than or equal to 0 and solve. So we're going to add 15 over. 3x is greater than or equal to 15. Divide by 3. X is going to be greater than or equal to 5. So this is the domain of this function. Instead of writing an interval notation, again, it's going to be domain. It's going to be 5. And since this is pointing to the right, it's greater than. So it's going to go to the right forever to infinity. This gets a bracket because it's not, or it is equal to, and infinity always gets a parentheses. Last, we have f of x equals negative x over the square root of negative x minus 2. And again, we're going to do negative infinity to positive infinity, just as our basis to start off with. Now this has both a fraction and a square root in the denominator. So remember, we can't have this equal to 0, but we set this greater than or equal to 0. So we're going to do kind of a compromise. We're going to take the bottom without the square root, and instead of setting this greater than or equal to, we're just going to set it greater than 0 because we need to get rid of the equal to part. And then from here, we just solve. Add 2 over, negative x is greater than positive 2, and multiply or divide by a negative 1, x is going to be less than negative 2. So for our domain, we can say that this is negative 2, and this is less than or going to the left, so it's starting off at negative infinity. Again, a parentheses there, and since it's not equal to, a parentheses here. So the domain of this function goes from negative infinity to negative 2.